Welcome to the course Ergonomics in Automotive Design. Now, we are going to discuss about our ninth module, that is virtual ergonomics evaluation technique and its application in automotive design. Under this module, we will cover three topics. First one, fundamentals of digital human modeling. Second, that is the part 1, which will deal with accommodation, clearance interference, posture, comfort discomfort and reach evaluation for the drivers in various vehicles. And the third one, that is the part 2, it is dealing with vision and ingress egress evaluation. Now, first, before going to discuss about digital human model, what is digital human model or what is digital human modeling process, before that we should know what is virtual simulation. So, virtual simulation is the CAD generated environment or computer graphics environment where we can do different types of evaluation, different types of representation of human activities. Now, digital human model and mannequin are also CAD generated model which we use for the purpose of ergonomic evaluation of product and workstation. We will discuss in details in subsequent slides. Now, if you look at this left side panel, there the digital human model and mannequin, how it is used. So, whatever left side panel, it is a working scenario in real factory shop floor in an industry. So, how workers are working or how different human are involved in different types of activities and what type of problem they are facing in terms of physical and biomechanical load and in terms of visibility, in terms of their task performance. So, those aspects we can simulate in digital human modeling software. So, if you look at the right side panel, the real activity has been simulated in virtual environment with digital human models. So, you can see that person is picking up the chairs, the same thing we can simulate in CAD software. So, this type of softwares are called digital human modeling software. So, what is digital human modeling software or what is digital human model? First, digital human model, if we define, so a computer aided mannequin or digital model is defined as the 2-dimensional or 3-dimensional computer graphics representation of human body based on anthropometric and biomechanical data, measurements, link and joint structure, movement characteristics as defined by CEN 2003. So, in general we can mention the digital human model is the computer graphics representation of human body or body parts to evaluate various ergonomic aspects of the product or workstation, and for developing this type of human model we incorporate anthropometric and biomechanical data. Now, digital human modeling as the process. So, this is the procedure of building, creating or designing such models for ergonomic evaluation process. Digital representation of human inserted into simulation or virtual environment to facilitate prediction of safety and or performance as defined by Demirel and Duffy 2007. Now, digital human model is an attempt to represent the complex human activity being digitally in both physical and cognitive aspect. So, complex human activity is represented in terms of physical and cognitive aspects in digital environment. Now, DHM can be broadly categorized into two, one is physical digital human model, another is cognitive digital human model. This physical digital human model deals with anthropometric, biomechanical, physiological aspect, whereas cognitive digital human model is dealing with human behavioral aspect, artificial intelligence, neural networking, etc. Out of these two types of digital human model, in the present module, we will mainly concentrate on the physical digital human model, because cognitive digital human model is still in nascent state, it is in development phase. So, more development is going on, and that is why in the current module we will concentrate our discussion only on physical digital human model. Now, physical digital human model is of two types, one is biomechanical model, another is 2-dimensional or 3-dimensional structural model. Under biomechanical model, what we discuss, the different body parts, its biomechanical aspects related to mass, related to motion, related to joint kinematics. So, for that purpose we can develop hand model, leg model or spinal model, whereas under 2-dimensional or 3-dimensional structural model, there is the human representation of human body form. So, here we use this type of software like Jack, SAMI, Ramsys, Delmia and there are so many other softwares available commercially. And for biomechanical model, we can give some example like 3D SSPP, then 4D Wattbag, NIOS and Snook tools, ArgoShape, Madimo. These are the few examples of biomechanical digital human model. Now, the first digital human model was introduced long back in 1960s. Its name was Bowman. Later on, subsequently so many softwares evolved, came in the market, and many of them also abolished. So, right now whichever softwares are available commercially, here are the few examples: Adapus, Anybody, Anthropos, Buford, Car, Combiman, Reuchef, Cyberman, Envision, Argo, Argodata, Argoman, ArgoShape, Frankie, Argospace. So, these are the various digital humanoid softwares which are developed or manufactured by different organization, as it is listed here. You can see these are the list of developer or manufacturer. At the same time, many of these softwares have been used for ergonomic evaluation of product and workstation, which have been reported by various researchers. That references are also available in the last column. Similarly, few other sets of software you can see in this particular slide: Jack, Mannequin, Sammy, Tadafs, Werner, Ramses, SafeWork, Delmia, EMA, Mannequin Pro, Santos. So, these are other softwares and these are popularly used in the industries. And who are the developer? That is listed in the column 2, and some references related to these softwares are available in column 3. Out of these softwares which are highlighted with yellow color like Jack, Sammy, Ramses, Delmia, these are popularly used all over the world. And recently the Santos software developed by University of Iowa under their virtual soldier research program, this software is very good and this is also being marketed. This is one of the best software with so many advanced features. Now, moving to the application of digital human modeling software, in which fields this type of softwares are being used nowadays. If we look at this diagram or image on the left panel, so you can see DHM has got its application in almost every fields wherever human being is involved. It is related to computer aided engineering, its application is in automotive or any other industries, in aerospace engineering, industrial sectors, then healthcare, occupational safety, then service industries, then defense research. So, in this way, if we look at almost every aspects of life where human beings are involved, we can simulate the human activity using digital human modeling software. Thus, application ranging from video games, television, movies, virtual reality, ergonomics, teleconferencing, medicine practice, biomechanics and so on. So, here are the few list of application areas as we mentioned earlier also: computer graphics engineering, then defense research, automotive sector, industrial textile sector, automotive technology and so on. Now, why digital human modeling? Why this topic is important and why digital human modeling is also important for ergonomic evaluation? First, look at this image. It is taken from GeekCast 2012. So, the first, the program starting here, then concept freeze, then style freeze, then process development and last is the vehicle in the market. These three, the concept freeze, style freeze and the process development, these are coming under product development phase. Under this product development, first we are discussing or we are concentrating on occupant packaging, how that driver will be positioned inside the vehicle in terms of relation to other controls. For that purpose, seating reference point is important, seat travel length is also important, then various reach, postural comfort, clearance, these aspects are considered at the first phase during concept freezing. Then while we are thinking of the style freezing or finalizing the style, that time we are considering vision, reach, clearance, these aspects. Then various engineering consideration in the next phase, that is ergonomic review related to advanced design review, user scenario by different types of users starting from driver, passenger or other maintenance operators, and finally data management. The last phase, the data management, where we are discussing about the knowledge, IP, data exchange between various disciplines. So, in this way, in automotive sector, digital human modeling is actually being introduced from the very beginning, that is the starting from the conceptual phase and not only conceptual phase, we can mention that this is from the pre-conceptual phase. From the very beginning of the design development process, we need to consider proactively how human can be incorporated in the design process. Now, why this digital human modeling is important? First, customized human model. We can generate customized human model using digital human modeling software. What does it mean by customized digital human model? Mean we can develop digital human modeling software as per our requirement. It may be as per the age variation, children model, adult model or aged model. At the same time, we can go for sex variation, male model, female model. Similarly, we can create variation in terms of somatotypes, ectomorph, endomorph, mesomorph. We can also create human models based on percentile data, 5th percentile human model, 50th percentile human model, 95th percentile human model or a human model for a particular individual as per his body dimensions. So, different options are there, and accordingly as per our requirement, as per our targeted user population, we can create the human models, and those human models we can use for virtual ergonomic evaluation of the facility or the workstation. Now, we can go for repeated trial and modification in the virtual environment with the digital mannequin or human model. There is no extra cost incurred. For the initial setup, cost is involved, but when the initial setup of the computer hardware and graphics are established, then there is no extra cost. So, n number of times we can go for design modification, then repeated trials with the mannequin, and whenever we find out any problem or any design flaws, then again we can go for design modification. For that purpose, no extra cost is incurred. Then there is also not a requirement of physical mockup. The whole evaluation is possible in the virtual environment in the CAD software. Then this digital human model is also applicable in hazardous environment, for evaluation of hazardous environment, then inaccessible environment. For example, if we just talk about inaccessible environment, spacecraft. Before developing a spacecraft, it is not possible to evaluate. Before making the actual prototype of the spacecraft, it is not possible to evaluate. On the other hand, it is also not possible to evaluate the spacecraft workstation in the space, where we cannot send a real human being. On the other hand, where there is hazardous working environment like nuclear power plant, chemical workstation. So, in the workstation also real human trial is very difficult, unsafe. So, in this scenario, it is better to go for virtual ergonomic evaluation using digital human model. Then 3D visualization of digital man-machine interface, we can see, we can rotate the models from various angles, and we can visualize if there is any clearance interference related issues. Then there are so many other benefits like reduced project time scale, increased productivity, enhanced safety, optimized workspace. So, n number of benefits we can receive or we can achieve from application of digital human modeling. Now, we are going to discuss about the traditional approach, that is the real human physical mockup based trial versus the digital human modeling based approach. So, first we are going to discuss about the traditional approach, what are important points there and how it is different from the DHM based approach. So, first traditional practice of ergonomics evaluation using physical mockup has proved to be time consuming, expensive and risky, as reported by Hellender 1999. Then inability to repeated trial. In traditional approach, where real human, real physical mockup trial is going on, that time repeated trial and modification is difficult, because you cannot ask the participant to come many times. It is difficult to identify the targeted user population as per percentile anthropometric data. Then impossible to investigate in inaccessible and hazardous environment, that is unsafe. Then real human trial also overlook the problems related to anthropometric and biomechanical aspect of the during performing a task in many times. So, in this type of study, there is also overlook of problems related to anthropometric and biomechanical aspect of performing a particular task. Then modification and alterations in the workplace once designed and implemented are very difficult, as it incurs more time and huge expenditure of money. So, once the design is finalized, then it is very difficult for redesign and modification, because for that purpose raw material is required, manpower is required, and at the same time time is required. So, that is why real physical trial in mockup or prototype, that is costly and time consuming. This type of evaluation also impossible to validate design concept before development the actual hardware prototype. This is only possible after developing. So, this is in reactive in nature, but digital human model allows in proactive ergonomic evaluation. Now, digital human modeling based approach. In digital human modeling based approach, we can go for a repeated trial of man machine interface without incurring time and cost as found in physical mock-up study as stated by Hanson et al. 2006. Then quicker evaluation of the workplace or the facility or the product is possible. It is potential to be used in analysis of inaccessible and hazardous environment as we already discussed. Then validating the design concept for a prescribed population even before developing the actual hardware prototype, that is also possible. Mean we can go for proactive nature of ergonomic evaluation using digital human modeling software before developing the actual physical mock-up or prototype. Ergonomic evaluation using defined percentage digital human model of varying somatotypes, that is also being allowed by digital human modeling. Now, in continuation to the importance of digital human modeling, if we look at this particular graph where on x axis it is represented concept, design, engineering, prototyping, test, redesign. These are the various typical product and process development phase. On the other hand, on y axis it is shown development cost, that how much cost is involved for that particular developmental phase. Now, if we look at the blue graph, that is the initial, the blue graph which is related to traditional or serial design process using real human trial, real physical mock-up or real prototype. In that case, what is happening in the first phase concept design, the cost involved is low, but later on the cost is gradually increasing. So, in which phase prototype, testing, redesigning, that phase the cost is high. On the other hand, whenever we are going for the computer aided engineering, digital mock-up unit, or we are going for digital human modeling trial, then what is happening at the beginning stage is like concept, design, engineering. In those phases the initial cost is high, but later on cost is subsequently low. In later phases mean prototype, testing, redesign, then the developmental cost which is involved in these phases, those are very less. So, comparing this blue curve and the red curve, we can understand during the initial phases the cost for digital human modeling based approach is higher than the traditional approach, where more cost is involved in case of digital human modeling, because we have to develop the infrastructure for high end computers, then we have purchased the CAD software, we have to install, training is required, but once the setup is ready and concept development design is starting, then we can go for digital prototype mock-up development, then we can go for testing, we can go for redesign. For that purpose no extra cost is involved. But in traditional process, although initial cost is less in comparison to the digital human modeling or computer aided engineering based approach, but later on in the prototype, test and redesign phases the cost is very high in comparison to digital human modeling approach, because in that case while we are going for redesign and modification, then material, cost, manpower, everything is involved. Thus, although there is initial higher cost added by the computer aided engineering implementation, but the final reduction of cost if we look at, that is higher, reduced cost with shortened time and improved ergonomics. So, initial cost is relatively little bit high, but the final cost reduction is very much. So, that is why the use of digital human modeling or computer aided engineering is very much beneficial in comparison to the traditional approach of serial design process involving real human and physical mock-up or physical prototype. While there is an additional implementation and training cost in the initial phase, the use of digital human models, digital prototyping and virtual testing in a computer aided design or ergonomic process can quickly lead to reduced cost and shortened design time, as reported by Zhang and Chaff in 2005. Now, if we look at the evolution of digital human modeling software, that how it started and gradually how it evolved over the years and what is the current status. So, initially digital human models are stick figure like, then geometric primitive came, digital human modeling become like robot like appearance, it adopted, where there was primitive geometric shapes like sphere, cuboid, cylinder. Then complex geometric modeling with smoothing algorithm came, and digital human modeling, its feature are also improved. It came like human model with surface geometry. Then gradually there was incorporation of 3D body scanning data in place of the traditional physical measured anthropometric data. Then inclusion of motion capture data for real time manipulation of mannequins posture and activities. So, with the advancement of technology, digital human modeling software and its developments also moved forward. Incorporation of predictive dynamic human motion for realistic posture task simulation thus gradually came. Finally, realistic highest fidelity digital human models with finer details also came in the market, like skin deformation, muscle contraction, physiological aspects like respiratory rate, energy expenditure, those things gradually came in the digital modeling software. Now, if we look at this particular slide, where we can see the gradually how digital modeling software evolved. So, it started from the stick figure like appearance, gradually it moved to geometric primitives like robot like appearance, then wireframe like model, then shaded model with surface modeling, with smoothing algorithm we can see this type of dressed model. Then further advancement where there is muscle, ligaments, skeleton structure, and now most advanced digital human model with the feature like cloth wrinkles, body part deformation, then skin deformation, movements of body parts. With this type of real human like simulation now it is possible, as it is shown from the Santos software or from Delmia software. After discussing the evolution of digital human model, now we should know how these digital human modeling softwares are being used for various types of product and workstation evaluation, particularly for automotive design or automotive workstations. So, first if we look, that is the how digital human model is being generated. So, first we are concentrating on this portion 1, that is concept of DHM concept car model. So, for that purpose, if we want to develop digital human model for concept car model, then what is required? We require database of the drivers. So, we need anthropometric, static and dynamic dimensions, we need biomechanical data related to range of motion, force, torque. Similarly, we also need comfort range of motion data, single joint or multiple joint comfort databases. Now, based on this information, we can incorporate those information in the digital human model, and accordingly we can create our digital human models as per our requirement. That may be percentile digital human model, that may be subject specific digital human model. Now, after making the digital human models ready, we are also developing the digital mock-up or digital model of the car. So, for that purpose, what are the information required? CAD related information, need identification, design limit selection, design dimension, material selection, cost, 2D sketches, concept development. So, various information is required before developing the CAD model of the product, here particularly the vehicle. Now, those informations are used for various design variables, driver seat design, steering wheel, foot controls, hand controls, display board and various indicators. So, based on all these individual parts model, finally it is assembled and we get the car model or the vehicle model. Now, this is the two. These two, first one is the digital human model and second is the car model or the vehicle model. These two are brought to the computer graphics environment, that is the digital platform, where these two things are interfaced for further ergonomic evaluation. Then it is going for ergonomic evaluation, that digital human model interfaced with the product or vehicle model. After interfacing, then we can go for different types of ergonomic evaluation, like reach analysis, we can go for vision analysis, clearance interference analysis, ingress egress analysis, comfort analysis and various other types of analysis. Following all these analysis in the virtual environment of CAD software, if we find that okay, the design is proper, it is compatible with the human requirement or the user requirement, then we can go for final design concept and prototype making, and finally documentation and management. But if we find that there are some issues, design modification is required, then again we will go back to the redesign and modification of the car model, and in this way again redesign and modification of the car model, and then again interfacing with digital human model, and again the loop will continue until the ergonomic evaluation is complete and all the ergonomic evaluation criteria or aspect is full satisfied, then only we will move for prototype development and documentation. Now, as we discussed earlier, that first phase is the creation of digital human model or developing of the digital human model for ergonomic evaluation, and the second is the development of the product or the workstation. So, first, if we are going to developing digital human model, how should we proceed? So, in most of the digital human modeling softwares, there is this type of spreadsheet like interface, where various body parts are mentioned and how much is the value you have to put there. So, you can put hand length, leg length, head width, so the various variables listed there, and against each variables you have to put the value from the anthropometric databases. So, all over the world there are various anthropometric databases, size India, size Japan, size China. So, here few references are given where from we can get the anthropometric databases for a particular population. Based on that database, we can generate as per our requirement the digital human models. For example, we can develop the 5th percentile human model, 50th percentile, 95th as the representative of smaller body dimension, average body dimension and larger body dimension. So, these aspects actually covering the anthropometric variation of the human models. Beside this anthropometric variation, another important aspect is the biomechanical data incorporation. So, how we can incorporate biomechanical data in the digital human model? Subsequently, we can go for ergonomic evaluation. So, for biomechanical data incorporation, we need to know the range of motion, complete range of motion for each of the body joints, its degree of freedom and comfort range of motion. So, various databases are available related to range of motion data as well as comfort databases. So, based on the context, whether this is automotive industry or any other industry or what type of evaluation we are going to proceed, accordingly we have to select the comfort database and range of motion database, and we will go for ergonomic evaluation. So, here are some references provided. So, these references you can explore for incorporating range of motion data as well as comfort range of motion data. After using this anthropometric database and biomechanical database, when you are developing the digital human models of varying percentile as per your requirement, now the question is coming, how will you position those digital human models inside the vehicle or any other workstation. So, for that purpose, for proper giving appropriate posture and positioning the digital human model inside the vehicle or cab model or any other workstation model, we need some reference points. So, various reference points which are used in automotive industry or for vehicle design or occupant packaging, we discussed in our earlier modules. So, major reference points which are being used for automotive industry, those are H point, hip joint point, accelerator heel point, seating reference point, neutral seat reference point, seating reference point, and one more is the design eye point. This is not for automotive industry, this is used for aerospace and aviation industry. Now, the first few reference points which are being used in occupant packaging in the vehicle workstation, we discussed in earlier module. So, here you can see, if you look at this image, so this is the H point for the driver. So, how H point will be positioned? We will position, in other words, we will position the digital human model on the vehicle seat or the car seat based on the H point. H point for 95th percentile human model we mention as the seating reference point. So, while we are giving the 95th percentile digital human model a driving posture and putting their heel on the accelerator heel point, then we can adjust the seat as per our requirement. Similarly, while we are positioning 5th percentile or 95th percentile driver, accordingly we will move the seat to accommodate them in that vehicle. So, this is H point, this is accelerator heel point, and there is one example of view cone. So, these are the two important reference points for positioning driver model on the vehicle seat. In this slide, we are going to discuss that how digital human models and digital mock-up model or digital prototype of the vehicle or the workstation is generated and interfaced. So, we can generate or develop this type of CAD model of the vehicle or any other workstation in various CAD software. It may not be digital human modeling software. We can use other softwares like SolidWorks, CATIA, Unigraphics, different types of software we can use, and using the software we can develop the CAD model of the vehicle, and we can import the vehicle model or the workstation model in the digital modeling software. On the other hand, many of the digital human modeling software have to some extent the capability to develop this type of workstation model, but that is very limited. Now, digital human modeling software is also allowing to develop digital human models as per the requirement. So, for that purpose, as we discussed already, that we use anthropometric data, biomechanical data, and based on those anthropometric and biomechanical data, we develop this type of digital human model, which are generally we use 5th percentile, 50th percentile and 95th percentile model, which are the representative of smaller body dimension, average body dimension and larger body dimension. After developing this type of vehicle model and the digital human model, we interface these two. How this interface is happening? So, we give the appropriate posture, follow the reference points and position the human models inside the vehicle model or workstation model, and then we proceed for different types of ergonomic evaluation. So, what types of ergonomic evaluation is possible? So, here is the list. We can go for reach analysis, we can go for vision analysis, we can also think about the clearance dimensions when the driver or passenger going inside the vehicle, whether there is any clearance or interference, we can visualize that one, we can study the comfort discomfort, then fatigue analysis, whether the drivers are becoming fatigued, then various types of posture evaluation tools are available like Rula, OAS, NIOS. Based on that, we can go for analysis of the posture, then posture prediction. If we define the position of the foot pedals, position of the steering wheel, position of the seat, accordingly how will be the driver's posture, that also we can predict. Then lower back analysis or spinal load analysis for L4, L5 spinal compression force or shearing force, that we can also measure with this type of digital human modeling simulation. Then we can also calculate metabolic energy expenditure, we can calculate predefined time standard, then static strength prediction, and particularly for automotive industry, the Society of Automotive Engineering Packaging Guidelines for Vehicle Workstation Design and Evaluation. Now, after all this, we are going to discuss few research papers where they have reported about the application of digital human modeling for various types of vehicles workstation design, that may be passenger car, that may be truck or any other automotive products. So, Baumann 2001 demonstrated how digital human model can be used for analyzing reach and vision requirement as per the Federal Motor Vehicle Safety Standards. In another paper by Chiang and Wang 2007, they stated that the integration of dynamic simulation and ergonomic evaluation enables the system designer to visualize and improve workplace design in the digital space. Godwin et al. 2008, they investigated the line of sight issues from the operator's seated position within the cabin of LHD machines. Then Lamkel et al. 2009, they investigated to what extent ergonomic simulation of manual assembly tasks correctly predict the real outcomes in the automotive plants. And when we are using digital human model, how much it can predict the real scenario. Karmakar et al. 2011 demonstrated the application of digital human model for ergonomic evaluation of ingress egress process in an army vehicle. Summerskill et al. 2012 used digital human model based approach to identify blind spot in category N3 vehicles using SAMI digital human model system. There are so many other researchers all over the world who are using digital human modeling software in automotive manufacturing aspect, automotive assembly, then automotive maintenance. So, you can explore more research papers and conference proceedings for this purpose. Hinson et al. 2012 from their illustrative case study concluded that IMMA, that is intelligently moving mannequins ergonomic assessment module, is very promising for analysis of assembly of truck parts and also identified further scope of development of that particular software tool. Wang et al. 2013 proposed systematic approach to incorporate motion capture test and analysis in the integrated environment for vehicle design for analyzing human motions during vehicle ingress egress process. Liu et al. 2013 investigated the elderly people's motion strategies when entering and exiting the rear seat of minivans with sliding doors. In 2013, Baker et al. Investigated and reported the vehicle egress by military personnel following an accident when there is accident of the military vehicle, it is toppled down, that time how the soldiers can come or army personnel can come out from the vehicle, they demonstrated. In 2014, Guwahati demonstrated how digital human modeling can be used for evaluating various human factor issues in motor vehicle design. So, in this way there are numerous research work reported by the researchers and designers for successful application of digital human modeling for various stages of vehicle design and development process. Now, we are moving toward the next portion of our module, that is the part 1, accommodation, clearance interference, posture, comfort discomfort and reach evaluation in automotive product, particularly for the passenger car or other vehicle. So, how we use digital human modeling software for evaluation various types of vehicles. So, how we start? So, first we start with the selection of chassis. So, first we think about the chassis model in the CAD software, what will be the size and dimension. Then after the chassis is finalized, then we are moving for the giving appropriate driving posture of the drivers or other passengers and positioning them in that vehicle. For the positioning, as we mentioned earlier, reference point is very important. So, we have to think about the control position. So, after selection of the chassis, we have to locate the position of the various foot controls, accelerator, brake, clutch, and when we are giving the appropriate driving posture to the driver and putting the digital human model on the driver's seat, then foot of the driver or heel of the driver will be on the accelerator heel point, and accordingly based on the driving posture we will adjust the seat forward and backward to accommodate that particular percentile driver, larger driver or average driver or smaller driver. Accordingly seat will move forward and backward to accommodate drivers of different percentile dimension. So, this is the initial process. So, after positioning the driver model based on the reference points like accelerator heel point, then SGRP or any other seat reference point for 5th percentile and 50th percentile driver, then we can arrange all other controls and displays like steering wheel, then dashboard controls, dashboard displays around the driver and the passenger as per the requirement. So, it will ultimately help in the occupant packaging from the very beginning of the vehicle development process. After positioning the digital human model of driver or passenger, then we can go for different types of ergonomic evaluation for clearance and interference study, like how much head clearance is available for 5th percentile, 50th percentile, 95th percentile mannequin. Particularly it is important for the 95th percentile mannequin whose head height is or whose sitting head height is higher than the other percentile. So, how much clearance is available, whether that clearance is within the recommended limit or not, we can check it. Similarly, we can check it how much knee clearance or thigh clearance is available. We can also study the lateral clearance while driver and co-passenger or the passengers in the rear seat they are sitting. So, how much lateral space is available between two passengers or between the driver and the co-passenger, whether that space is sufficient or not, we can visualize and we can evaluate, and accordingly we can go for design modification. Now, here you can see if we position different percentile human model like 5th percentile female mannequin as the representative of smaller driver, then pooled data mannequin mean neither male nor female, that is the combined database of male female database, and from that we are developing the 50th percentile digital mannequin, we are positioning that one, and the 95th percentile mannequin. So, how is the variation in their accommodation or occupant packaging due to variation of their body dimension and accordingly adjustment of the seat forward backward. So, that is presented here. Next, arm reach envelope for steering wheel and other controls on the dashboard. With this type of digital human modeling software, we can create arm reach envelope. This envelope for arm reach or leg reach can be of different types. It may be normal arm reach or leg reach, extended one, comfortable one and constraint driven one. So, generally we can start the arm reach assuming that the seat belt is attached. When seat belt is attached, then hand movement is only possible from the shoulder joint. So, while the arm is moving and reaching towards the dashboard for various controls, then the starting point of joint movement is the shoulder joint. and accordingly we can create the reach envelope, that how much area or how much volume that driver or the driver mannequin can access. So, you can see the size is defined for 5th percentile, 50th percentile and 95th percentile mannequin. Based on this reach zone or reach envelope, we can finalize the position of the various controls and displays around the driver. So, obviously, this type of reach we should consider for 5th percentile female driver, because their body dimension or arm reach is relatively less. So, all the controls position on the dashboard or around her, she should be able to access. So, 5th percentile reach envelope is very important for this purpose. Then, if there is no seat belt, or if there is seat belt, but the person for the driver is extending his body forward, then actually the body movement is happening from the waist joint. When the body is moving from the waist joint, then the extended arm reach is more and they can access more area. So, that type of evaluation is also possible. Then there is also possible that how much area or how much reach is possible within the comfort hand movement or leg movement. Similarly, we can also go for evaluation of constant driven reach. Hand is moving only from the elbow joint or hand is moving only from the wrist joint. So, this type of evaluation is also possible in different types of digital modeling software. In the lower panel, we have shown that 5th percentile female mannequin, how is the leg reach envelope for 50th percentile pool data mannequin and 90th percentile male mannequin. So, this leg reach is important to understand, because based on that we can position the foot controls, and all those foot control should be accessed by the various percentile digital mannequin, so that in real scenario driver population with varying dimensions from 5th percentile to 90th percentile leg dimension, they can access the foot controls while the seat is adjusted forward and backward within the seat tractable limit. Now, how we can use digital human modeling software for evaluation of posture and comfort discomfort. As we discussed earlier, for comfort discomfort evaluation, it is important to understand the range of body motion, range of body joint, ROM, and at the same time the comfort range of motion within the total range of body joint movement. So, for that purpose, first what we need to do, we need to collect the comfort database and range of motion database. Based on the range of motion database for a particular body joint, for a particular degree of freedom, we can set the total range of motion. Say for example, if we take the example of elbow joint, then how much elbow joint can move. In the software, some value is already given. Assume for the elbow joint, the flexion extension value is given from 0 degree to 170 degree. But if you feel that you want to change that range of motion from 0 degree to 160 degree, you can change the joint limit. So, that type of options are available in the software. Then within this total range of motion, again based on the available comfort databases, you can define which range is comfortable and which range is not comfortable. Here if you look at this image, the left one where it is shown that the middle, this is the starting point and this is the end point. So, out of this whole range of movement, the first portion, that is the red, and this is not comfortable, the middle portion, that is the green zone, that is the comfort range of motion, and the final portion again the red portion, that is not comfortable. So, after defining this type of comfort zone within the total range of motion, we can go for evaluation whether for a particular activity or performing a particular task, the driver particular body segment is within the comfort zone or not. Accordingly, color coding is also there, color will be changed. Now, when the hand movement within this range, the color of the hand segment will become green. On the other hand, when the hand is moving in the red zone of the body joint movement, then the color of the hand segment is becoming red. So, if we can incorporate this type of comfort range of motion in the body joints and accordingly give the color coding, then whenever we are using that human model for ergonomic evaluation of the vehicle, for comfort analysis of the driver, automatically it will show which body parts is within the comfort or discomfort zone. So, comfort zone here it is for 90th percentile, it is shown green color, wherever it is showing green color mean those body parts are in comfort range of motion, whereas yellow mean little bit discomfort, and wherever it is red, that is completely discomfort in terms of body joint angle. So, apart from this type of comfort joint angle based comfort evaluation, we can also go for posture evaluation with the standard inbuilt ergonomic tools like WAS, Ovaco working posture analysis system, or ruler rapid upper limb assessment, REBA rapid entire body assessment. This type of posture evaluation tools are inbuilt in many of these digital modeling software, and we can use those tools for posture evaluation or postural load evaluation. Now, moving to the part 2, where we are discussing about the vision and ingress egress evaluation in vehicle workstations. So, there are various types of vision analysis tools available in different digital modeling software. Software to software it varies. So, for example, there is this type of view cone we can create from the eye point. We can create view cone of varying angles. You can see here it is shown that we can create view cone of 15 degree, 30 degree. As per our requirement, we can define the view cone and the size of the view cone also, mean in terms of distance, and accordingly we can check whether the particular object or particular display or controls is within the view field of the driver or not. Similarly, we can create the line of sight, that where the driver is looking at, how much is the neck angle, how much is the eye movement angle, we can measure using the line of sight. Similarly, there is field of view, while the mannequin is looking at a particular direction or particular position, that how much area of the external environment is visible through his eyes, that comes in a separate window, which is mentioned as the view field or eye view window. Then, due to presence of any object or any component, how much area is not visible to the driver or to the mannequin, that can also be evaluated using the tool obscuration zone analysis. There is also tool for vision analysis which is related to blind spot, which area are the blind spot zone for the driver or for the pilot or for any other workstation operator, and accordingly we will try not to put any of the control or display within the blind spot zone. In many of the software there is also a reflection zone. Say for example, particularly this is very much helpful for mirror view. So, while drivers are using different types of mirror, side view mirror or inside mirror, then how much area is visible to the driver, that can be evaluated using reflection zone. Now, here are some example how we can use digital modeling software and vision analysis tool for vehicle inside or outside visibility evaluation. So, we can create 15 degree view cone. So, here in this top one, the example we have position 5th percentile female mannequin, and we are showing that for 5th percentile female mannequin at least 15 degree downward visibility below the horizontal eye level should be there above the bonnet, so that she can see the road properly. So, in this particular example, so this is the zone in front of the vehicle which is not visible for the driver. So, this is the dead zone for the this 5th percentile driver. Above this zone it is visible for the driver, but this distance from the front portion of the vehicle is not visible to the driver. So, if small objects or animals or a kid pass by this area, it will not be visible for the driver. On the other hand, it is important to evaluate the upward visibility for the 95th percentile or larger driver. So, for any vehicle, while we are deciding about the lower edge of the roof or the top edge of the windshield, then we have to decide that for the 95th percentile driver at least 15 degree upward visibility should be there, so that the driver can see the external images like hoardings, signages, traffic signals while he or she is driving. So, for this purpose we position 95th percentile male model which are larger in body dimension, and for them at least 15 degree upward visibility through the windshield in front of the vehicle should be available. And while the drivers are looking forward, then how much area is actually visible, that is coming in this type of eye view window. Apart from this vision analysis, digital modeling software is also helping in ingress egress analysis. So, various aspects of ingress egress analysis, mean while the driver or passenger is going inside the car or any other automotive vehicle and coming out, then what type of problem they are facing and how much is or how much comfortable that entry exit we can evaluate using digital human models. So, various aspects of entry exit which we can evaluate with digital human model, those are door opening dimensions, then collision during entry exit, step over width, floor height, then door handle, grab handle, handrail position, then step dimensions for stairs or ladders. So, these are the various aspects which are associated with the entry exit process for the drivers and passengers. So, these aspects we have to check one by one through digital human modeling simulation. So, in the first panel we can see that ingress egress evaluation for shorter driver. Here it is that we are showing with 5th percentile mannequin. So, how the driver is coming out or going inside the vehicle step by step, and each and every step whether they have any difficulties in terms of holding grab handle or the dimension of the door, then how much is the step width, how much of the is the height of the vehicle floor, and accordingly whether they are facing any difficulties or not. If we find yes there are some issues related to these aspects, then we have to redesign that automotive product to make it compatible or comfortable for the all percentile of driver population. Similarly, while the same vehicle is being used by a 95th percentile mannequin, which are the representative of drivers with larger body dimension, then we can see how they are performing the ingress egress activity, and accordingly if there is any design loopholes, then we can go for design modification. So, in this slide we are presenting some of the important online resources where we can get information about various digital human modeling software like Santos, EMA, Jack, Delmi or AMSYS. So, you can explore these web links for knowing more about the software. Now, after discussing all these things, we are coming to the conclusion that what are the key learnings from this module 9. So, in this module we have discussed about the definition of digital human model, various types of digital human model, particularly we discussed about the physical digital human model where we mentioned about 2-dimensional, 3-dimensional representation mannequin as well as biomechanical mannequin. Then importance of digital human model in virtual ergonomic evaluation, why we are using digital human model. Then digital human model softwares which are commercially available starting from Bowman in 1960s up to date, where there are so many advanced softwares like Santos, Jack, SAMI, AMSYS. Then milestones of evolution of digital human modeling software, how digital human modeling software evolved over the years starting from the stick figure to the realistic human model in current scenario. We also discussed about how digital human model is interfaced with the CAD model of the product or the workstation or vehicle model, and how we can proceed for various types of ergonomic evaluation. Then virtual ergonomic evaluation using digital human model, various aspects, reachability, clearance, interference, comfort, discomfort, entry, exit, vision. So, these various ergonomic evaluation aspects we also discussed. Then how digital human model is used in automotive design, particularly for vehicle occupant packaging and evaluation, we also discussed with some examples. Now, these are the list of references which has been used for various slides. So, you can go through these references for detailed understanding of this topic and how digital human model is being used by various researchers, why this software is important for virtual ergonomic evaluation of automotive products. So, these are the references. Thank you.